Hello everyone, this is Manish Shrivastava. In today's session, we will discuss about nuclear technology. As you know, nuclear technology is very important in terms of UPSC as well as to make the country carbon free. It is the most important source. While we talking about the nuclear technology is mostly dependent on the radioactive materials and the substance who emit alpha, beta and gamma radiations. When we talk about the nucleus of any atom, then the nuclear technology comes into the picture. While talking about in terms of UPSC, there are so many questions are coming from this particular topic. That's why we are discussing this topic of every segments which are related to it. So, firstly, we will discuss about what is nuclear technology. We have multiple kind of nuclear power plants in India. There are multiple treaties are going all over world. While we talk about non-proliferation technology, NSG, CTBT, there are so many things which are associated with it. But in today's session, we will discuss about how this nuclear technology is crucial for us, what is nuclear technology, and what are the different aspects of it. If we go through this particular topic, right now in all over world, 10% of electricity is generated by nuclear energy, and India is also following that path. That's why we want to build more and more nuclear reactors. And in future aspect, it is considered that around 20% of global electricity must be produced from this particular nuclear energy. So let's start with this particular topic, that is nuclear energy. So first thing, what is nuclear energy? So nuclear energy is the energy released from the nucleus. As you know, nucleus is the centermost part of any atom, which contain protons and neutrons, which is considered as the mass of a mass of a particular atom. As you know, we just take an example of any kind of atom like carbon. Carbon has 6 atomic number and 12 atomic mass. As you know, 6 is the atomic number, and atomic number denotes that number of protons present in it, and whatever the number of proton is present in any particular atom, that is always equals to the number of electrons. And when we talk about the atomic mass, like here, it is considered as this is atomic number. And atomic number is always equals to number of protons. But when we talk about this upper part, this is atomic mass. And what is atomic mass? Atomic mass is the sum of proton and neutron. So as you know, in the smaller classes, when we talk about any atom, it have one nucleus that was discovered by Rutherford, and outside of it there are several orbits in which electrons are there. Like we take the example of carbon. Carbon have atomic number of 6. Atomic number always represent number of protons. Means 6 is the number of proton present in carbon. Here we are talking about carbon. So carbon have number of protons, have 6, and this formula is always associated with it. Whenever the number of proton is 6, it means that exactly the same number is of electron, because number of proton is always equals to number of electron. So in case of carbon, we have 6 proton. If 6 proton are present in carbon, then definitely it have 6 electron in it, and it is distributed in this form. In the first orbit there are 2 electrons, and other 4 electrons are distributed in the second orbit, which are negatively charged. But when we talk about this particular thing that we call nucleus, the nucleus is associated with its atomic mass. And when we talk about atomic mass, it have both the things, proton and neutron. So when you add the number of proton and neutron, it will become the atomic mass. Means carbon have atomic mass of 12. Atomic mass of carbon is 12. It means that proton and neutron will make this sum equals to 12. As we know, there are 6 proton in it. So we have to add 6 plus something to make it 12. So that something is also 6. That's why we can claim that proton is 6 and neutron is also 6. So this is equals to 12. Means the whole mass of this particular carbon atom is associated, or in other terms we can say that the whole mass of this particular atom carbon is found in its nucleus. But in some atoms, some scientists have discovered that, in which I can recall the names of those scientists. Those are Henry Becquerel, Madame Curie, and Robert Peire. These 3 people discovered a concept of radioactivity. Radioactivity was discovered by these 3 personalities who got Nobel Prize for this particular thing, that is radioactivity. In radioactivity, every term, every atom have a nucleus which is unstable. In this case, the carbon have a stable nucleus. But when we talk about some kind of atoms like plutonium, thorium, radium, uranium, those metals have unstable nucleus. And to stabilize their nucleus, they used to emit alpha, beta and gamma radiations lifelong. After emitting all those radiations, they converted into the lead. So in this particular chapter, when we talk about nuclear energy is the energy released from the nucleus. And why this is happening? Because their nucleus are unstable, or core of an atom, which is composed of proton and neutron, that we are discussing. If a metal or a non-metal or a metalloid or any kind of atom have some atomic mass, then that atomic mass is always equals to the number of protons and number of neutrons. And those neutrons and protons are present in their nucleus. And if their nucleus is unstable, then they used to stabilize themselves. And during those time when they stabilize themselves, they release some energy. That is in the form of alpha, beta and gamma radiations. So nuclear energy is produced in 2 ways, that is nuclear fission and nuclear fusion. These are the 2 things which are associated with this. This particular reactions can be done right now in the nuclear reactors, which was discovered by Enrico Fermi, a professor in the Chicago University. So America had gifted a kind of instruments which is very crucial for producing nuclear energy. And as we say that the power generates from the nuclear energy is about 10% of global electricity. And in future aspect, which is rising to nearly 20% in advanced economies. While it faces challenges in some countries, like India is also dealing with it, America is ready to provide us thorium based reactors, that is SMR, that is small modular reactors in which we are working. So it is historically one of the largest global contributors to carbon free electricity, and right now the demand is carbon free electricity, because all world is facing a problem, a challenge, that is global warming. And global warming is due to the different kind of greenhouse gases, and in that greenhouse gases, carbon dioxide, methane, nitrous oxide, sulfur hexafluoride, nitrous trifluoride, fluorine, like chlorofluorocarbon, perfluorocarbon, hydrofluorocarbon, all are affected. So if we want a kind of alternative of it, nuclear technology is the option. And in nuclear technology, we have multiple kind of options that we are discussing today. So as you know, the nucleus, when the nucleus become unstable, it started radiating alpha, beta and gamma radiations. In terms of alpha, beta and gamma radiations, we talk about 2 reactions, that is nuclear energy is energy released from nucleus of an atom, and it is associated with 2 things, means nuclear energy is produced in 2 ways. First is nuclear fission and another is nuclear fusion. We will discuss about the difference between them, but in simple terms, as you know, in Hiroshima and Nagasaki on 6th and 9th August in 1945, America deployed 2 bombs on 6th August in Hiroshima and on 9th August in Nagasaki. Those 2 bombs are based on this particular thing, that is fission. So it means that atom bomb are associated with fission reaction. But when we talk about hydrogen bomb, it is nuclear fusion reaction. Fusion is something a kind of integration when the atoms combine together. It means that join two or more lighter atoms into a larger one. Fusion creates a larger one nuclei, while we're talking about the fission reaction splits a larger atom into two or more smaller ones. So fission is a kind of breaking down of things, while fusion is an integration of things. But when we talk about those two things, hydrogen bomb and atom bomb are 1000 more times, 1000 times more powerful than atom bomb. So it creates more destruction, and this is the reaction that is happening in the sun, our sun, which is the source of energy. Secondly, nuclear fusion reaction is very risky, because for controlling these reactions it needs a very good kind of reactors, and that is the risk associated with it. While talking about fission, it is also risky, but comparably it is more less risky than the fusion reaction. If we talk about a reaction, I just write a reaction about the nuclear fission. What is the purpose of this particular reaction? How the energy is created in it. But when we talk about like this particular thing, nuclear fission, we take just a small reaction like uranium. If we bombard it with a neutron in a reactor, it will split into barium and krypton. Along with three neutrons, and a lot of energy will release. And this energy is capitalized into multiple things. That's we are dealing with this particular thing. Right now, 10% of global electricity is producing from this particular kind of reactions, in which we can take any kind of material like plutonium, radium, thorium, as well as we can take uranium, that is most common radioactive element. This radioactive element is the key of this particular reaction, because it have unstable nucleus, and that unstable nucleus is crucial for this nuclear technology. Right now, as we are studying about the nuclear fission and fusion reaction, just take a small note about it. What is the basic difference between nuclear fission and the fusion reaction, that will be discussed in some times. So as we are approaching towards the what is the difference between those of them. So first thing, fission is breaking down, and when we talk about fusion, it is integrating or combining together. So let's start with the difference between what is difference between the nuclear fission and fusion. So as you are able to see this slide, so we just make a difference in both of them, like nuclear fission and nuclear fusion. A heavy nucleus breaks up into two lighter nuclei. So when heavy nucleus is converted into lighter nuclei, that is fission reaction. But when we talk two nuclei combined to form a heavy nucleus, that is fusion reaction. It involves a chain reaction, but it does not involve a chain reaction. The heavy nucleus is bombarded with neutrons. When the heavy nucleus formed, it create a kind of neutrons. Like in this reaction, we have this particular thing, and this is the neutron thing. Light nuclei are heated to an extremely high temperature. That's why we are talking about the fusion reaction. Sometimes it becomes uncontrollable due to its high temperature. So that's why it is more risky comparable to nuclear fission reaction. We have a proper mechanism to control fission reaction for generating electricity. So right now in all over world, 10% of global electricity is formed from the nuclear fission. But when we talk about the fusion reaction, proper mechanism to control fusion reaction are yet to be developed. Means it is under process, but when we talk about fission, it can easily be controlled and can be used for generating electricity. Moving forward, disposal of nuclear waste is a great environmental problem. Due to nuclear fission, there are a lot of nuclear waste, nuclear waste as well as the solid materials which are creating from it create a mess in the world that have a lot of environmental issues. But when we talk about the nuclear fusion reactions, disposal of nuclear waste is not involved. The main problem is controlling that reaction. Apart from it, raw material is not easily available and is costly. When we talk about uranium, plutonium, those are metals which those are the things which are very costly and which are not easily available. That's why right now you have heard a topic about the rare earth metals and critical earth metals. The deal has happened between America and Ukraine. That's why America is using the resources of Ukraine. Ukraine have multiple kind of things like uranium, titanium, lithium. That's why America is imposing that particular treaty to just provide us all the things which can be very helpful in the nuclear energy as well as in the electric vehicles, because lithium is also a kind of tool that is used in particularly in the EV electrical vehicles. Elon Musk, Tesla is associated with it. Apart from it, when we talk about the rocket fuels, rocket reactors, titanium is multiple times used in aircraft and all those things which are associated with it. When we talk about the those particular things, so right now America is very much interested in Ukraine due to this particular thing. They have a lot of resources, and you become little surprised after knowing that Ukraine have 958 lakh crores of those critical and rare metals, which is very crucial for US economy. That's why US is much interested in the Ukraine things. Apart from it, raw material is comparatively easily available and cheap and easily available in terms of nuclear fission. The main headache is the controlling of this particular thing. Apart from it, everything is fine. Now we move forward, and when we talk about nuclear energy, these two reactions are associated. But when we talk about nuclear energy, how this energy can be created? So you will say that we just go through a reaction, that is nuclear fission or fusion, and we can easily create energy. But the main headache is to form that nuclear reactor. That reactor is very important, very crucial, which was a brainchild of Enrico Fermi, who is the professor in Chicago University. So America had discovered this particular thing that is very crucial for forming nuclear energy. Those are reactors, and we have multiple type of reactors that reactors are using in so many countries. I give just an example of a boiling water reactor. This boiling water reactor is used in 4 countries right now in world, and around 15% of global reactors are of boiling water reactors. Right now, when we talk about Sweden, Taiwan, Japan and US, these are the 4 nations which are very much interested in boiling water reactor, and that is around 15% of the global demand. Means if we count all the reactors which are present in all over world, 15% out of which are considered as boiling water reactors. But there are also a different kind of reactors. We will talk about them also. Like this is a reactor in which we use fuel, we use controllers, control rods, we use moderators, as well as we use coolants. These are the components of a reactor, and by this a lot of energy is released, which helps to move the turbine, and that create electricity which is very crucial, and that is carbon free. Because when we talk about the 1992 Earth Summit, in 1992 in Brazil, Rio de Janeiro, a summit has happened named as United Nations Conference on Environment Development, UNCD. It is also known as Earth Summit. It is also known as Earth Summit. In this Earth Summit, 5 topics have discussed, and those 5 topics are climate change, biodiversity, forest, talking about the management of the forest, sustainable development, that is Agenda 21, and about the desertification, in which a more important topic, that is climate change, and in this particular conference a body had created that is known as UNFCCC, United Nations Framework Convention on Climate Change, and that is meeting every year, termed as COP, and that COP is mainly for carbon, because this climate change is triggered due to the excessive carbon presence in our atmosphere, and which is happening by the multiple sources like the fossil fuels which are using in abundance amount in all over world. So that's why UNFCCC conduct a meeting that is known as Conference of Party, and there have multiple meetings happen after 1994, in which 95 it happened in Geneva, 96 it happened in Berlin, in 97 it happened in Kyoto, and right now there are 29 meetings has happened so far. The last meeting has happened in Baku, Azerbaijan, and the 30th meeting will be held in 2025 in Brazil. That's why all over world is trying to create an alternative of the carbon, because in every whenever a combustion of a fuel is happening, that's create a mess, because carbon is the main component coming out of it. That's why this kind of electricity is the best source and the best material in terms of that thing. That's we are most relying on this particular thing, or that's why I'm saying that nuclear power generates about 10% of global electricity, and in future we are moving towards the 20% in advanced economies. That's why we are dealing this particular thing, and that is crucial for all over world. We can't discriminate the developing nations from it. While we seeing the global distribution, developing nations are working on it. Developed nations already installed it, already installed those kind of plants in their country, but everyone wants to install this particular thing in more and more capacity. That's an alternative source, because it is a carbon free electricity, and that is a global contributor to carbon free electricity. That's why we are focusing on this thing. Next thing, the components of nuclear reactor, it have fuel, and fuel are of multiple types. It have controlled rods, moderators, coolant, and steam generators, and all those components helps to form this particular kind of energy, which is used for electricity formation. And right now global electricity is 10% dependent on nuclear energy. So these components helps to run this particular reactor, and that reactor is very crucial for generating nuclear energy. Moving forward, what are the different kind of reactors we can use, and what are the different shares in global economy of the reactors? First, in PHWR, this is pressurized heavy water reactors, in which heavy water is used. If you are confused with this term heavy water, what is heavy water? As you know, hydrogen have one electron and one proton. It don't have any neutron. That's why hydrogen is only the atom in the periodic table whose atomic number and mass number are same. As I had discussed earlier, the atomic number always denotes number of protons. So it have proton that is equals to 1, and that's why electron is also equals to proton. So in this way we can conclude that hydrogen is an atom which have 1 proton and 1 electron. When we talk about the atomic mass is always equals to the sum of neutron and proton. So when we add neutron and proton, we already know the value of proton. So what should be added? Atomic mass is also 1. So 1 equals to neutron plus 1. So what should be added to 1 to create it 1? So just create it 0. So 1 equals to 0 plus 1. It means that hydrogen don't have any neutron. But in chemistry, we talk about a term that is known as isotope. Isotope is that element which have same atomic number but different mass number. Same atomic number but different mass number. So when we talk about this, hydrogen have multiple isotopes. You can surprise by the name, like this is hydrogen, this is deuterium, this is tritium. This is hydrogen, this is deuterium, and this is tritium. But when we talk about this deuterium, it have extra 1 neutron, it have 2 neutron. So when we compare with this hydrogen and deuterium, deuterium is more heavy than the hydrogen. That's why deuterium is also known as heavy hydrogen. Heavy hydrogen. When we talk about water, we can denote it by H2. But when we denote D2O, it's become, this is normal water. Lekin D2O is known as heavy water because it had formed from the deuterium, 1H2. So when we talk about pressurized heavy water reactor in which we use heavy water, and what is heavy water? The heavy water is associated with deuterium. So deuterium water is used in this particular pressurized heavy water reactors. Canada is the main manufacturer of this particular thing, and globally 11% of the reactors are of a kind of pressurized heavy water reactor. Second thing is light water reactor. Light water reactor are the most common reactor in all over world, which contribute about 70%. It have 2 types. First is pressurized water. Pressurized water reactor. Pressurized water reactor have a normal kind of water, and second is boiling water reactor, that is known as BWR. And I had already discussed about boiling water reactors here. In Sweden, Taiwan, Japan and US, which have 15% global contribution, have boiling water reactor, and boiling water reactor is a kind of light water reactor. Light water reactors which contribute 70% of the global demand. And the third one in which India is right now working is free breeder reactor. Free breeder reactor. This free breeder reactor in which we can use uranium, and right now India is working for PFBR, that is prototype free breeder reactor, and America is assisting in it, as well as small modular reactor which have less amount of power generation, less than 700 megawatt. So we are working on it right now in the free breeder reactor, and till 2032 we have a aim of producing around 7,000 megawatt of from free breeder reactor, around power of 7,000 megawatt. So that is our future aspirations from this particular thing. And right now in Tamil Nadu, Kalapakkam, we are developing a prototype free breeder reactor with the help of America. Moving forward, when we talk about the what are the advantages of this particular nuclear energy that we are discussing in today's session, first thing is space exploration. For space exploration, you need a good kind of fuel for launching any kind of rocket, for launching rockets, as well as the satellites associated with it. Right now we have multiple vehicles for space exploration. As you know, we talk about PSLV, GSLV, GSLV Mk3. This is also known as LVM3. But when we talk about these particular thing, ISRO has already discussed about in next terms, ISRO will generate next generation launching vehicle. Next generation launching vehicle can lift 30,000 of payload up to 500 kilometer. That are the future aspirations of ISRO. But right now, ISRO have these three launching vehicles. Earlier two are also there, named as ASLV and SLV3. But these two got retired. SLV third was the first launching vehicle of India in the year 1980. In 1992, we have ASLV. In 1994, we have PSLV, 2001 GSLV, and in 2014, we got GSLV Mk3. But when we talk about PSLV, it have 4 stages, and it mostly rely on fuels like solid fuels, liquid fuels, solid fuels, and liquid fuels. So it depends on these 2 fuels, but have 4 stages. But when we talk about GSLV, it have 3 stages: solid, liquid, and cryogenic. GSLV Mk3s also have solid fuel, liquid fuel, and cryogenic fuel. When we talk about cryogenic fuel, it is mainly needs liquid hydrogen and liquid oxygen. But for space exploration, we need a more kind of energy, a more kind of a strong rocket. So in that thing, we can use nuclear energy, and that will help to uplift or give that kind of thrust to carry out heavy projects. Right now, ISRO capacity, when we talk about PSLV, it can lift 1750 kg of weight. GSLV, it have 2050 kg of weight. But when we talk about GSLV, it have 4000 kg of weight. In future, we will lift 30,000 also. So in that terms, we need a kind of energy that is associated with nuclear energy. You got surprised by knowing that Elon Musk reusable launching vehicle can lift a weight of 1,50,000 kg. If we want to create that kind of power, we must need a nuclear energy in space exploration. So that's why we can take the advantage of nuclear energy in the space exploration. Like we are planning for Venus orbiter mission in future, as well as we are talking about Gaganyaan, Mangalyaan second. So in that we can use that particular energy. Apart from it, in agriculture we can use nuclear energy. You will say, how can we use nuclear energy in agriculture? You got surprised by knowing that our food processing department, which was led by Mr. Chirag Paswan, who is right now the Minister of Food Processing, it had recently launched a scheme known as Sampada. In that Sampada Yojana, particularly food which got food processed by to get rid of bacteria, they are providing the gamma radiation to the agriculture crops to sustain it more time when we talk about the export things. For sterilization, we can use sterilization process which are very associated with the radiations in the food. Electricity, As you know, 10% of global electricity is associated with it. And in the medical field, a brain tumors like things, and in the cancer treatment, we can use these particular radiations and make a healthy world. So these are the advantages of nuclear energy in these particular aspects. Now, when we talk about this particular thing, we are talking about the positive aspects, but lot of challenges are associated with it. First is it is very costly to create a nuclear power plant, to create a safe kind of environment, that is very much associated with it, and to create that much of thing, a large amount of money, a large lump sum money is required. So first challenge is associated with this particular thing is cost. Second is exposure to the radiation, because it have harmful radiation. When we talking about the Henry Becquerel, Madame Curie, Robert Peary, all those persons who dedicated their life in the research of particular things which have alpha, beta and gamma radiations, they got affected by the cancer. So radiation causes a lot of risk for the humankind. Secondary thing which is associated, the challenges in it, is its risk of accident. Chernobyl, Fukushima, we have multiple examples. Large operating costs, as I had already discussed, as well as the nuclear waste which are associated with the nuclear fission reaction, that we already discussed. Apart from it, radiation exposure are the main challenges which are associated with nuclear technology. But these challenges is very important to get rid of all the risk things associated with it. If we remove those challenges by creating a good kind of solution, then nuclear technology is the global solution of carbon free electricity. So we have to take care of all those aspects which are associated with nuclear technology, and in terms of India, we are working on it. So that is a small brief discussion about the nuclear technology. Hope you like that particular thing. Please provide me a good kind of feedback for this particular thing. So maybe you are now little bit comfortable in this particular topic. So that's all from the nuclear technology. Thank you very much for watching this. Have a great day.